Hi, I'm Alex. This is Oh, That's Why, a podcast about JavaScript, finally making sense. Let's dig in. Last week, we discovered something. JavaScript doesn't just run your code the moment you hit run. It prepares first. Scans everything, registers variables, stores functions, sets up the environment, and only then does it start executing. But here's what I didn't tell you last week. That preparation, that setup, it doesn't just happen once. It doesn't just happen at the top of your file and then disappear. It happens every single time a function runs. Every single time. And what gets built, what JavaScript creates before it runs any piece of code, has a name, a specific, important name. And understanding it is the key to understanding almost everything else in this series. So let me ask you something. When JavaScript runs a function, any function, what does it actually mean for that function to run? Where does it run? What does it have access to? What is this inside it? Most developers have a vague sense of the answers. Vague. I was vague for a very long time. Every piece of JavaScript runs inside a context. What is that exactly? Let's build the room. Before we get into any JavaScript, I want you to picture a room. Not a fancy room, a working room. The kind a detective might use to solve a case, or a project manager running a campaign. A room that exists for one specific purpose, to contain everything needed to do one specific job. Now, this room has three things in it. First, a whiteboard. On this whiteboard is written every variable that exists for this job. Every name, every value, everything that was declared. It's all up there. If you need to know what a variable is, you look at the whiteboard. Second, a map on the wall. Not a map of a city, a map of other rooms. Because sometimes what you need isn't in this room. Sometimes a variable lives in a room outside this one. The map tells you where to look next. And if it's not in the next room, the map shows you the room after that, all the way up until you reach the very first room that was ever created. Third, a nameplate on the desk. It says whose room this is, who is responsible for this job, who this refers to inside this room. That is an execution context. Every time JavaScript runs a piece of code, it builds one of these rooms, sets up the whiteboard, hangs the map, puts the nameplate on the desk, and then runs the code inside that room. When the code is done, the room is cleaned up. Sometimes it disappears entirely. Sometimes, and this is where closures come from, which we'll get to in a few weeks, sometimes the room leaves something behind. But for now, just hold that image. The whiteboard, the map, the nameplate. Every piece of code gets its own room. Every room has those three things. Now let's look at what JavaScript actually calls them. When JavaScript creates an execution context, that room, it puts three things inside it, and they have names. The whiteboard is called the variable environment. This is where all the variables, function declarations, and arguments for this piece of code live. When JavaScript needs to look up a variable, it checks the variable environment first. If the value is there, done. If it's not, it goes to the map. The map is called the scope chain. This is the link to the outer environment, the room that existed before this one was created. If JavaScript can't find a variable in the current room, it follows the scope chain outward, looking in each surrounding room until it either finds it or runs out of rooms to check. This is lexical scoping. The scope chain is determined by where the code was written, not where it was called from. That distinction is important, and we are going to spend a whole episode on it. The nameplate is called the this binding. And look, I know, This is one of those things that makes developers want to close their laptop and go do something else. The reason it's confusing is that this isn't fixed. It changes depending on how the function was called. But that is a story for Season 2. For now, just know it lives here in the execution context, and it is set when the room is built. Okay, variable environment, scope chain, this binding. Those are the three things inside every execution context. Now, there is one more thing to understand. Not all execution contexts are created equal. There are two kinds. The first is the global execution context. This is the very first room JavaScript builds, before any of your code runs. It is built once, lives for the entire lifetime of your program, and is where all your top-level code lives. The global object, window in a browser, global in Node, lives here. And the this at the top level points to it. This is the room we talked about last week during the memory creation phase. The second kind is the function execution context. Every time a function is called, not defined, called, JavaScript builds a new room for it. A brand new variable environment, a scope chain linking back to wherever the function was written, and a this binding determined by how the function was called. And here's the part that ties everything together. Remember last week, the two phases? Those two phases don't just happen at the global level. They happen inside every single execution context. Every time JavaScript builds a room, global or function, it scans first, then runs. The pattern is the same all the way down. So the execution context is not just a concept, it is the mechanism. It is how JavaScript organizes every single piece of code that runs. Every variable lookup, every function call, every this reference, they all trace back to the execution context those things were created in. Now that you understand what an execution context is, let me show you where most people go wrong. The first trap, and this one is absolutely everywhere, is confusing where a function is defined with where it is called. The scope chain, the map on the wall, is built based on where the function was written, not where it was called from. This catches people constantly. You call a function from one place, it behaves like it lives somewhere completely different, and you have no idea why. The reason is simple once you understand it. When JavaScript built the room for that function, it hung a map that pointed back to where the function was written, not where you called it from. The room remembers its origins, not its caller. The second trap is assuming this is always the same thing. This one has cost developers so many hours, including me. This is set fresh every time a new execution context is created, and what it points to depends entirely on how the function was called, not where it was written. Pass a method to a callback, call it as a plain function, use an arrow function. This changes in each case. People spend hours on this because they think this is fixed to the object it was defined on. It is not. It is part of the room, and the room is rebuilt fresh every time. Third trap, and this one is the quietest. Maybe the sneakiest. Arrow functions do not get their own execution context in the same way. They do not get their own this binding. They inherit this from the room they were created in. This is why arrow functions behave differently in event handlers and class methods. Not because of syntax, but because of how their execution context is built. We will come back to this. But know that the room for an arrow function is genuinely different from the room for a regular function. These are not edge cases. Every JavaScript bug involving a wrong variable value, an unexpected this, or a function that can't find something it should be able to find, traces back to execution context. And now you understand why. The execution context is just JavaScript's answer to three questions. What do I have? Where do I look? And who am I right now? That's it. Everything else, closures, scope, this, is a consequence of how JavaScript answers those three questions every time it runs a piece of code. Once you see that, the rest of Season 1 is going to feel like dominoes falling. If you want to see this in code, the companion article on Medium walks through real examples. Same concept, concrete and visual. Link is in the show notes. Next week, the call stack. Every function call builds a new room, but those rooms have to go somewhere. Next week, we find out where they stack up, what happens when too many pile on, and why your error messages always come with a list of rooms attached. It's going to be good. I'm Alex Vega. This is Oh, That's Why. Every room JavaScript builds is a small act of preparation, and now you know exactly what's in each one. See you next week.